Alright, welcome to our notes on 2.9. So we look here at section, proving lines are parallel, and our objective. We're going to use angle pairs, the same angle pairs that we introduced in 2.7, along with the converses that we're going to introduce right now to prove lines are parallel. So before, in 2.7, we used our angle pairs, corresponding, alternate interior, and so on, to figure out if the angles were congruent. Now we're going to use the converses. If you look down the list, converse, 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 to prove lines are parallel. So if we look here, corresponding angles, converse. We know the theorem said if lines are parallel, then the angles are congruent. Here, if the corresponding angles are congruent, because it's the converse, if the corresponding angles are congruent, then the lines are parallel. So again, it's an if-then. If corresponding angles are congruent, then the lines are parallel. So what does that look like? This means in this situation, we're looking at something where we've got lines L and M. They're not labeled as parallel. They're just two lines. And then we have something where we have something like angles 1 and 2 are labeled as congruent with the congruent angle signs, or maybe the measures are the same. And so because we can see that angles 1 and 2 are congruent, then L and M are parallel. So once we've said that by the converse, then we could label them parallel and go from there. So our purpose here is we're looking for, this would be something where we're given the angles are congruent in some way, and then we can conclude that the lines are parallel. And so this is the converse. We know that the converse is not always true, and so here we're writing this down because this converse is true. This is a theorem. The converse is also true. From there, we probably have a good idea of what's going to happen next. Each of our theorems is going to give the converse. So here, alternate interior angles are converse. When alternate interior angles are congruent, because in the theorem they were congruent. If the angles are congruent, then the lines are parallel. Why are we writing it a couple of different ways? So you've got one that really connects and helps you remember the concept here. And each time we'll sketch L and M. Now this would be like a different situation. If we'd already used the corresponding angles converse, we'd already know these lines are parallel, so we wouldn't have to use another theorem. But maybe we have another example where we've got, for example, let's say angles 3 and 4 instead are congruent. So somehow we're able to say that angles 3 and 4 are congruent. If angle 3 is congruent to angle 4, then the lines are parallel. All right, at this point, we definitely know what's going to happen next. Alternate exterior angles, if they're congruent, then the lines are parallel. So each theorem gets a converse. Each one gets a converse. Let's say on this one we've still got L and M. We'll say 5 and 6. Maybe they're not labeled as congruent with the symbol that way, but maybe we're given that measure of angle 5 is 80 degrees and measure of angle 6 is 80 degrees. So maybe over here somehow we know that they're congruent. And in that case, if angle 5 is congruent to angle 6, and so we'd spend a little time explaining that angle 5 is congruent to angle 6, then L and M are parallel. So again, they have the same purpose no matter what, to show that the lines are parallel. And then last, consecutive interior angles. And we remember that consecutive interior angles in the theorem were supplementary. Then the lines are parallel, so the converse will say the same thing. If consecutive interior angles are supplementary, the same thing as before, then the lines are parallel. So here, maybe we're looking at angles 7 and 8, where measure of angle 7 is 100, measured angle 8 is 80 if angle 7 and 8 are supplementary, then the lines are parallel. And then we get one more, which is perpendicular transversal. Why is this useful? This is the same as all of the other ones. We have some situation where we've got a couple of angles and they're each perpendicular. So you notice that depending on which angles I label as right angles, we might be able to use the corresponding angles converse, or if this is 90, we know this is 90, so we can use vertical angles and say that alternate interior angles converse. We can actually use any of the converses because we know all of these angles are right angles. Sometimes, and it's not necessary, but sometimes it's just nice to remember that we have another converse, that anytime we have two lines that are perpendicular to the same line, which will be the transversal, anytime two lines are perpendicular to the same line, then they are parallel. So this would be a situation, we'll call this L and M, and we'll call this N. If L is perpendicular to N, and M is perpendicular to N, so they're both perpendicular to the same line, then L and M are parallel. So it's a nice little shortcut. We're not going to use it a lot, and a lot of times we would just simply use corresponding or alternate interior angles converse or one of those, but if we wanted to, we have another way of wording this. So let's flip to the back and let's do two examples together. Now, a lot of what we'll do in class will be examples of which lines are parallel in a given situation. And this, in these proofs, we'll be able to do essentially the same thing. So we'll notice what we're given here. In this example, we're given that Q is parallel to R. And then we can look at the figure and we notice good that these are already labeled for us. Q is parallel to R. And that 1 is congruent to 3. And that's given. And so in order to go from there, we've got a couple of given information. One, we have parallel, which makes us think back to our earlier sections. If lines are parallel, then we'll be able to say angle pairs are congruent and so on. Here, angle 1 congruent to angle 3. We can look at the figure. That's not an angle pair, so right away that might not be helpful. And then we can look at our goal here. P is parallel to T, so we want to show that these two lines are parallel. What I think is really helpful here is to come up with a goal before we even start. And we can take a look, and based on the angles that are labeled here, we can kind of think, okay, if we can show that angles 1 and 2 are congruent, because that's an angle pair, we'd be able to show that P and T are parallel. So if we can show that angles 1 and 2 are congruent by some other way, then we can then say that P and T are parallel. So there's our goal. Let's try to get to 1 and 2. So that's all based on the proofs table. Let's try to get to angles 1 and 2 here. We have 1 and 3. And so we say, okay, what else do we know about angles 1 and 2? If we look at angles 2 and 3 here, we can kind of cover up this transversal. We look at angles 2 and 3, and we say that those are corresponding angles. Corresponding angles with a transversal of P, which means these corresponding angles are going to be congruent as long as these two lines are parallel. Those two lines, Q and R, great, we know that's true. We know Q and R are parallel, which tells us that angle 2 and angle 3 are congruent by corresponding angles theorem or postulate. So again, this is kind of thinking back to 2.7. If the lines are parallel, then angle pairs are congruent. Which angle pair? Well, we can say 2 and 3. We notice it's not the one we wanted right away. We wanted 1 and 2, but we didn't know those lines are parallel, so we couldn't jump right to 1 and 2. That's what a lot of these are going through, making sure that the lines that we use or the angle pairs we use have the correct information here. Now that we have 2 and 3, we can say, all right, we got 1 and 3, we've got 2 and 3, we know how to combine those two. The arrows are more important than where I write anything. I can combine 1 and 3 with 2 and 3 and say, okay, so angle 1 is congruent to angle 2 by the transitive property of congruence. Now we have angles 1 and 2 are congruent. So now we think back to what we just learned. Angles 1 and 2 are congruent. I can look at these. These are alternate exterior angles with a transversal of Q. And so we're able to find by just the given information that angles 1 and 2 are congruent. And if alternate exterior angles are congruent, then we know, if the alternate exterior angles are congruent, that the lines forming those must be parallel. And so this is an example of the alternate exterior angles converse, because we've gone backwards. We've gone from angles being congruent to lines being parallel. And something that's useful to go back and look at. Here's a theorem where we go from parallel to congruent. That's a theorem. Here's a converse where we go from congruent to parallel. And so that's a really good example. When you feel really comfortable with an example like number 1, then you know you're in really good shape with this section here. This is a great example to look at, and we'll go over a similar one in class. Now let's slide down to example 2. So this one, we're given a little bit different information. We're given that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So we're given some angles that are congruent, and we want to show that n is parallel to t. So n and t, we notice, so maybe we come up with a goal right away. Sorry, n and p. We want n and p to be congruent. And we notice here, by the angles that are labeled, probably like 3 and 5 is a good goal to get to. 3 and 5, we already have something about 3 and 4. But we don't have a lot to work with because nothing's parallel. So maybe we start by looking at angles 1 and 2. Angles 1 and 2 are corresponding angles along the transversal of n, which means right away we can say 1 and 2 are congruent. They're corresponding angles. That tells us that L and M must be parallel. Why? This would be the corresponding angles converse. Corresponding angles are congruent, so the lines must be parallel. Why is that helpful? Well, if we know that L and M are now parallel, now I can label it because we know they're now parallel. Now they're now parallel, any angle pairs along L and M then have to be congruent as well. And so we can look and say, okay, is there any other angle pairs that we can work through here? We already know 1 and 2 are congruent. 1 and 3 are not an angle pair, so maybe we don't use that one. We could always label something there that's not, but let's, for simplicity, let's avoid that. If we look down here, 4 and 5, if we cover this up, 4 and 5 are an angle pair. 4 and 5 are alternate interior angles, which means since L and M are parallel lines, here's our transversal P. So we're just looking at this here. 4 and 5 are alternate interior angles. The lines that we wanted are parallel. L parallel of M tells us that angle 4 must be congruent to angle 5. Why? This would be alternate interior angles theorem, because we're going from parallel to congruent. Why is that helpful? Well, we can combine 3 and 4 and 4 and 5. And if we combine those, angle 3 is congruent to angle 5. This is transitive property. Why did I keep heading toward those? Because we know our goal was 3 and 5. We kind of circled those as that's an angle pair that helps us with N and P. Notice that we had to take kind of a long route here. We had to go grab another pair of parallel lines. Why? Because it helped us. We had information that jumped right to there. Once we've got 3 congruent to 5, then these are corresponding angles. Again, a lot of corresponding angles in this one. Corresponding angles. N must be parallel to T by corresponding angles converse. So there's a lot going on here. Think about what we did. We had a pair of corresponding angles right away, so let's say those two lines are parallel. Might not have known right away why that would be helpful, but we were given that information, so let's write it down. Then later we found out that looking at L and M being parallel, that we could say these two angles were congruent, which we could use the transitive property to get to 3 and 5, and then use the corresponding angles converse to put that all together. We'll do the third example together in class.